we know what a percent is, let's talk about a little bit more about proportions with percents. And we've already done proportions. We know how to figure out proportions and ratios. So let's just tie all of this together. So again, let's review. Remember that all fractions, which extend to ratios too, which we've been talking about pretty exclusively here, have at least one other fraction or ratio, if we're talking about ratios, name that is equivalent. So that goes back to the triple FP, the fundamental fact of fraction pairs. There's always a value that has several fraction names to it, depending on how you partition that segment, and then it just affects how many copies you have. For example, 5/6 is the same point or same value as 10 12ths, or 65 copies of 1/78. So again, if you have 5/6, you can partition the sixth into smaller pieces, which means you're going to get maybe partitions of 12, but then 5 copies is going to end up being more copies, and that would be 10, so 10/12. And if you did it again, you could get 65/78, or there's an infinite amount of possibilities you could have for that same point on the number line. Another example, using ratios, 3:7 is the same ratio as 15:35, or 36:84. So those ratios are all proportional because they're all the same point, or they are comparing the same size number sets. So a set size of 3 is comparable to 7, just as 15 is the same ratio as to 35, or again 36:84. And we know that we use the cross multiplication theorem to check whether two fractions, or again ratios, are equivalent or proportional. So again, this is used with fractions, ratios, because they're all set up very similar. Or if we're not checking to see whether they are equivalent, we can use cross multiplication theorem to find a missing value that will make an equivalent fraction or proportional ratios. For example, if I have 9/5, or if you want to say it in a ratio, 9:5, is it the same, or is it proportional, or is it equivalent to 81/45? And again, you can see the question mark is there because this is a test. We're testing to see whether it is. So using our cross multiplication theorem, we're going to multiply 9 times 45, and 5 times 81. Because again, what we're leaving out is the fact that we are multiplying 5 times 45. It's just we don't need to know that number. We're just checking to see if the numerators are the same. And when we do that, 9 times 45 is 405, and 5 times 81 is 405. So therefore, we can say that these are equivalent fractions or proportional ratios. But what if you have 9/5, and I want to know what is an equivalent ratio, or equivalent fraction, or a proportional ratio to partitions if it's partitioned into 50 parts? I want to know how many copies do I have? So again, using cross multiplication theorem, I do 9 times 50, but now I have 5 times some number is the same as 9 times 50. So by simplifying 9 times 50, I get 45, and 5 times some number, in this case x, is 5 times x. Well, if I want to know 5 times what number is equal to 450, the easiest thing to do is to divide by 5. And when we do it algebraically, we want to isolate the x, so we divide both sides by 5, and 450 divided by 5 is 90. So basically what we're saying is 9/5 is equivalent to or proportional to 90/50, or 9 to 5 is the same as 90 to 50. All right, so how does this work with percents? Well, using percents and proportions, or equivalent fractions, is the same as proportions between ratios and equivalent fraction between fractions. So there really is no difference. So a typical question you may see is, what is 14% of 45? So we want to find out if 14% means 14 out of 100, or 14 hundreds, then what would the number of copies be if the partitions are only 45? So it would be set up as 14 over 100 is the same as some number over 45. Then by using cross multiplication theorem, 14 times 45 is equal to 100 times x. Well, 14 times 45 is 630, and 100 times x, it can be rewritten as 100x. And then 100 times some number is going to be 630. So the inverse of multiplying is dividing. We're going to divide both sides, in which case x becomes 6 3/10, or we're going to write it in its decimal format as 6.3. So again, what this means is 14 out of 100 is equivalent to 6 3/10 over 45. And basically what we're doing is we're answering the question with the statement 14% of 45 is 6 3/10. All right, here's another one, slightly different. 23 is 55% of what number? So now I have part of 23, but I want to know 23 out of what? And we want 55%. So again, if 55% is the same as 55 over 100, then 23 is part of some number that we don't know yet. So in this case, our missing number is the partitions. What is this group partitioned into? I've got 23 copies of it, but 23 out of what? So again, setting up the cross multiplication, we have 55 times x and 23 times 100. When we simplify that, we get 2300 equals 55x. Well, 55 times some number is 2,300. And in order to figure that out, we can divide. So dividing by 55 is actually 41 and 9/11, because 9/11 is a repeating number. So in this case, it's better to leave it in its fraction format. So our missing partition is 41 and 9/11. So what this really means is 55 over 100, or 55%, and 23 is 55% of 41 and 9/11. So this is how you would make that statement in answer to the question. All right, last one. 19 is what percent of 25? So now I want to know what out of 100 is 19 of 25. And this would be typical when you want to figure out what is your percent on, let's say, a test. If you got 19 correct out of 25 questions, what percent did you get? So since we're missing what the percent is, we know that it's some number out of 100, and we know that the total partitions is 25, and the copies we have is 19. So again, some number over 100 is going to be the same as 19 out of 25. And doing the same process again, 19 times 100 is the same as 25 times x, which simplifies to 1900 equals 25 times some number, We're going to divide by 25, and 1900 divided by 25 is 76. So the answer to this question in proportion form is 76 out of 100 is the same as 19 out of 25, or 76 hundredths is the same as the fraction 19 25ths. And to answer our question, 19 is 76% of 25, or what you might hear is 19 out of 25 is 76%. All right, this link is attached to your homework on the class page, and the answers are at the end of it if you'd like to practice these types of problems, again using the percent proportion. And we will look in on this in class.